In section 10.3, we're going to talk about hyperbolas. So hyperbolas are a little bit tricky to draw, so I'm not even going to try to. I would write all of these down. These are all the properties of a hyperbola centered at 0, 0. Two different types that we have are horizontal and vertical. The key difference to notice here, knowing if you're horizontal or vertical, if you're looking at an equation or making an equation, is the order of your x and y values. So one way that I look at it is that if you have a horizontal hyperbola, the x is first. And in a vertical hyperbola, the y is first. Notice that our a squared values and b squared values don't change order here, regardless of what equation that we have, okay? But the order of the x and y values tell us if this is horizontal or vertical, okay? Next part here, going into talking about your vertices, stuff like that. If you have a horizontal hyperbola, your vertices will be on the x-axis, so the vertices will look like positive and minus a, comma 0. For vertical, that's going to be on the y-axis, so it'll be 0, comma, plus or minus a. And finally, when we're trying to find focus points or maybe a v value or a missing value, we use basically just the Pythagorean theorem. But c squared, or our focus point, c squared equals a squared plus b squared. And our asymptotes for these graphs, or those lines that our graph can't cross, are now going to be diagonal. So we're going to go through some ways of how we could sketch that by hand in this video. So in example number 1, we have a hyperbola centered at 0, 0, and it has vertices at negative 4, 0 and positive 4, 0, and one focus at 5, 0. And to start here, want to just write standard form of this hyperbola. So looking at this, I have my vertices. I look at that. So since that's my vertex, I know that my a value is 4. My focus is at 5, so my c value is 5. Also, since I see that vertice is a, comma 0, that would be on the x-axis, so I know that this is a horizontal hyperbola. First, let's find our b squared value before we put this into an equation. So 5 squared equals 4 squared plus b squared. 25 equals 16 plus b squared. 9 equals b squared. 3 is our b value. When we plug this in, it'll be b squared, which is 9. Since this is horizontal, this is the format of the equation that we're going to use, so my x squared value is going to go first. I plug in my a squared and b squared value, and I'm done. In part 2, this is where it gets a little bit trickier. I want to sketch the parabola, or hyperbola, not a parabola. Parabolas come later in this unit. So I have my equation here. And what I'm going to want to do is first I'll graph my vertices, since I know those are at positive 4, 0, negative 4, 0. And then my b value, I'm going to go up 3 and then down 3. And this is going to help me make my asymptotes. So what I'm going to do here is a little bit weird. I'm going to kind of sketch some dots up and over. Basically, this is going to make my slope for my diagonal asymptote. I'm going to do this on every corner. And this will kind of, so I can do a little trick with this. I'm just going to draw a diagonal line through the corners of that rectangle that I made. And those are going to be the asymptotes for my hyperbola. Since this is horizontal, I want these to go through the vertices. So when I sketch my graphs, I keep them inside the asymptotes so they don't cross them. And that would be my graph, just sketched out by hand. In the next and last example problem that we do, what are the vertices, foci, and asymptotes of the hyperbola with the equation 9y squared minus 7x squared equals 63? And I want you to sketch the graph. So first what we'll want to do to get into standard form is we need that constant value on the other side to be 1. So easily how we can do that is I'm just going to divide by itself. So I'm going to divide everything here by 63, and now I'll have my equation in standard form. My new equation would be y squared over 7 minus x squared over 9 equals 1. So I have my equation, now I can find my important pieces from there. So technically, since y has a positive coefficient, or to put it simply, the y value is first here, so I know that this is a vertical hyperbola. So this is my a value, your a value will always be first, but my a value is going to be the square root of 7, plus or minus. And again, since this is vertical, I know that that's where this is going to look on the graph. 0, comma, then my a value, because it's got to be on the y-axis. My b value is the square root of 9, so plus or minus 3. Using that information, I'm going to be able to find my foci. So I plug these in, C squared equals 7 plus 9, which is 16. My C value is 4, so my focus points are at positive and negative 4. So now when I make my graph, I'm going to focus on my A and B values. I'm going to go up and down square root of 7, which is around 2.65, so I can just kind of estimate that. And I'm going to go over left and right 3. Same thing here. I'm going to kind of plot my corners here to make a rectangle. So then to make my diagonal asymptotes, I'm just going to draw a corner, or draw through the corners here. Since this is a vertical hyperbola, this is going to look a little bit different than my last example. I'm going to draw my hyperbolas this way. And again, I'd be done.